Good evening, ladies and gentlemen. My name is Belady, and you might know me after an operating system problem that is named after me called Belady's Anomaly. I discovered my anomaly while researching a memory caching algorithm in 1966 while working at IBM Research. Today I will explain to you just what my anomaly is all about. Now imagine you are a bartender and that you make drinks using flavored ice cubes. In this analogy for the computer system, the bartender would be acting as the CPU or processor. They would be making the demands as to what they needed to assemble the drinks, and the ice cubes would act as their building blocks. Imagine that each ice tray is a container for a memory address. Each individual space for an ice cube would be known as a frame. This is the physical representation of memory on a CPU. The actual contents of the ice cubes, however, would be what we call pages. Paging is a way that computers use to control how its virtual machine's memory resources are shared. I have limited amount of slots to give, therefore I have to be careful how I split up my resources. I can give a few slots to Kool-Aid, a few slots to water, a few slots to cranberry juice, and a few slots to orange juice. If there is room in one slot, I can even share or combine 2 or more beverages. I can even leave a slot or more empty if I don't need them. Now I'm sure that all of you are tired about learning about operating systems, so let's go fix ourselves a drink. So we're going to ask our bartender to make our signature drink, Belady's Mocktail, involving 2 parts water, 1 part Kool-Aid, 1 part orange juice, and 1 part lemon juice. The drink represents a process our processor is trying to make. My drink only gets a limited amount of ice cube slots for its ingredients. Say we start with 3 ice cube slots. The bartender begins to use the ice cubes one by one, but then we have a problem. Our bartender goes looking for a page that we don't have in memory. This is known as a page fault. In order to solve this problem, first we must remove the ice cube from the frame to make room for more. Then we need to go into the freezer, which is also known as our backing store, and get a new ice cube. Great, now we have the next ice cube, but the next time we go to get one, we run into the same problem. We have another page fault. Now, what are some ways in which we can solve this problem? What if we just had bigger ice cubes that had all the flavors we wanted? Then we would have fewer page faults because although we are only allowed 3 frames, these frames are big enough to accommodate our needs. Alternatively, we can just give our process a bigger allowance of ice cube frames. Then our page fault rate is sure to decrease. Like this. More frames for our processes means less page faults, and therefore our bartender doesn't have to keep going to the freezer to get new ice cubes. Are you quite so sure of that, dear boy? Whoa, Belady, I forgot this video was about you.
Normally, I'd say you're right. That graph you had there looked pretty solid. But in my tests, I noticed something strange. When I gave the process more frames, it actually gave me more page faults.
Wait a second, but that doesn't make any sense.
You're right. It's garbage. It's illogical. It's an anomaly.